that's, well, like I said, we'll have a production intent prototype ready to show off in, Q1, probably February or March. Yeah, we're going to be building a, million unit Optimus production line, hopefully with a production start towards the end of next year. Ultimately, we'll do Optimus 4, that'll be, 10 million units. Optimus 5, maybe 50 to 100 million units. I mean, it's really pretty nutty. That's my biggest concern. If we build this robot army, do I have at least a strong influence over that robot army?
What are the present challenges in bringing Optimus to market, considering app control software, engineering hardware, training general mobility models, training task-specific models, training voice models, implementing manufacturing, and establishing supply chains?
Yeah, I mean, bringing Optimus to market is an incredibly difficult task. To be clear, it's not like some walk in the park. At some point, I mean, actually, technically, Optimus can walk in the park right now. We do have Optimus robots that walk around our offices at our engineering headquarters in Palo Alto, California, basically 24 hours a day, 7 days a week. So any visitors that come by, you actually you can stop one of the Optimus robots and ask it to take you somewhere, and it'll literally take you to that meeting room or that location in the building. So I don't want to downplay the difficulty of Optimus. It's an incredibly difficult thing, especially it's difficult to create a hand that is as dexterous and capable as the human hand, which is the human hand is an incredible thing. That the more you study the human hand, the more incredible you realize the human hand is, and why you need 4 fingers and a thumb, why the fingers have certain degrees of freedom, why the various muscles are of different strengths, the fingers are of different lengths, and it turns out actually that those are all there for a reason, and so making it the hand and forearm, because most of the actuator, just like the human hand, the muscles that control your hand are actually primarily in your forearm. The Optimus hand and forearm is an incredibly difficult engineering challenge. I'd say it's more difficult than the rest from an electromechanical standpoint. The forearm and hand is more difficult than the entire rest of the robot. But really, in order to have a useful generalized robot, you do need an incredible hand, and then you need the real world AI, and you need to be able to scale up that production to have it be relevant, because it's not relevant if it's just a few hundred robots. But so you need to be able to make Optimus robots at volumes comparable to vehicles, if not significantly higher. So if you're trying to make 1 million or something per year, trying to make 1 million Optimus robots per year, that manufacturing challenge is immense, considering that the supply chain doesn't exist. So with cars, you've got an existing supply chain. With computers, you've got an existing supply chain. With a humanoid robot, there is no supply chain. So in order to manufacture that, Tesla actually has to be very vertically integrated and manufacture very deep into the supply chain, manufacture the parts internally, because there just is no supply chain. So this is the kind of thing where I'm like, if I put myself in the position of a startup trying to make a humanoid robot, I'm like, I don't know how to do it without an immense amount of manufacturing technology. So that's why I think like Tesla's in almost a unique, I think unique position when you consider manufacturing technology scaling, real world AI, and a truly dexterous hand. Those are generally the things that are missing when you read about other robots, that they just don't have those 3 things. So no, I think we can achieve all those things, those 3 things, with an immense amount of work, and that is the game plan. So, you know, my fundamental concern with regard to how much voting control I have in Tesla is, if I go ahead and build this enormous robot army, can I just be ousted at some point in the future? That's my biggest concern. If I that is really the only thing I'm trying to address with this. So it's called compensation, but it's not like I'm going to go spend the money. It's just, if we build this robot army, do I have at least a strong influence over that robot army? Not control, but a strong influence. That's what it comes down to in a nutshell. Like, I don't feel comfortable building that robot army if I don't have at least a strong influence.
Great, thank you. We've already covered robotaxi expansion. Unfortunately, the question after that is another future product question, so we're going to have to skip that. The next one, though, is, can you update us on the $16.5 billion Samsung chip deal in Taylor? Given the importance of semiconductors to autonomy in Tesla's AI-driven future, what gives you confidence Samsung can fulfill AI6 at Tesla's timelines and achieve relatively better yields and cost versus TSMC?
Okay, so I'm gonna give quite a long answer to this question because I have to unpack this question and then answer the unpacked version. So first of all, I have nothing but great things to say about Samsung. They're an amazing company, and Samsung, it is worth noting, does manufacture our AI4 computer and does a great job doing that. So now with the AI5, and here's I need to make a point of clarification relative to some comments I've made publicly before, which is we're actually going to focus both TSMC and Samsung initially on AI5. So the AI5 chip design by Tesla is, I think it's an amazing design. I have spent almost every weekend for the last few months with the chip design team working on AI5. And I don't hand out praise easily, but I have to say that I think the Tesla chip team is really designing an incredible chip here. This is, by some metrics, the AI5 chip will be 40 times better than the AI4 chip. Not 40%, 40 times. Because we have a detailed understanding of the entire software and hardware stack. So we're designing the hardware to address all of the pain points in software. So I don't think there really isn't anyone that's doing this, the entire stack, all the way through real world, calibrating against the real world where you've got cars and robots in real world. That, like, we know what the chip needs to do, and we know what, just as importantly, we know what the chip doesn't need to do. To sort of give you some examples here, with the AI5, we deleted the legacy GPU or the traditional GPU, which is it's in AI4, but AI5 does not have. We just deleted the legacy GPU because it basically is a GPU. So we also deleted the image signal processor, and there's like a long list of deletions that are very important. As a result of these deletions, we can actually fit AI5 in a half reticle, and with good margin for the traces from the memory to the Tesla trip accelerators, the ARM CPU cores, and the PCI X the PCI blocks. So this is a beautiful chip. I've poured so much life energy into this chip personally, and I'm confident this is going to be a winner next level. So it makes sense to have both Samsung and TSMC focus on AI5. And so even like technically the Samsung fab has slightly more advanced equipment than the TSMC fab. These will both be made in the U.S. In one TSMC in Arizona, Samsung in Texas, and but it's we're going to make, starting off, just to be confident of having our goal, explicit goal, is to have an oversupply of AI5 chips. Because if we have too many AI5 chips for the cars and robots, we can always put them in the data center. So we already use AI4 for training in our data center. So we use a combination of AI4 and NVIDIA hardware. We're not about to replace NVIDIA, to be clear, but we do use both in combination, AI4 and NVIDIA hardware. And the AI5 excess production we can always put in our data centers. NVIDIA keeps improving. The challenge that they have is that they've got to satisfy a large range, a lot of requirements from a lot of customers. But Tesla only has to satisfy requirements from one customer. That's Tesla. That makes the design job radically easier, and means we can delete a lot of complexity from the chip. I can't emphasize how important this is. So like when you look at the various logic blocks in the chip, as you increase the number of logic blocks, you also increase the interconnections between the logic blocks. So you can think of it like there's just highways. Like, how many highways do you need to connect the various parts of the chip? And especially if you're not sure how much data is going to go between each logic block on the chip, then you kind of end up having giant highways going all over the place. It becomes an almost impossibly difficult design problem, and NVIDIA's done an amazing job of dealing with almost an impossibly difficult set of requirements. But in our case, we're going for radical simplicity, and the net effect is that I think AI5 will be the best performance per watt, maybe by a factor of 2 or 3, and the best performance per dollar for AI, maybe by a factor of 10. So, that's, we'll have to, the proof's in the pudding. So obviously we need to actually get this chip made and made at scale. But that's what it looks like.
Taking the question. Elon, I know that Tesla's really focused on, with Master Plan 4, bringing AI into the physical world. And I think we've seen over the past, this willingness for Tesla to engage and go into new markets, new TAMs. So when you think about the growth prospects, how do we define the areas that are really within Tesla's core competency versus where do you draw the line for markets or AI applications that are outside of Tesla's core competency?
Actually, I'm not sure what you mean by AI applications outside of Tesla's core competency. But and we didn't have any of these core competencies when we started, So it's like we had 0 core competencies, total competency of 0, actually. So you can think of Tesla as, like, I don't know, a dozen startups in one company. And I've initiated every one of those startups. So it's we didn't used to make battery packs, so stationary battery packs, but now we do. We make them for the home, make them for utility scale with Powerwall Megapack. We created the supercharger network globally. No one else has created a global supercharger network. In fact, that North American supercharger network is so good at that basically every other manufacturer in North America has converted to our standard, and uses the Tesla supercharger network. But if it was so easy, why don't they just do it? And the chip design team started that from scratch. The Tesla AI software team was started from scratch. I literally just say, hey, we're going to start this thing. I post it on Twitter, now X, and then, join us if you'd like to build it. In fact, Ashok was, I believe, the first person I interviewed for the Tesla Autopilot team, which we now call the Tesla AI software team, because it is the AI software team. So, it's core competencies created while you wait. Optimus at scale is the infinite money glitch. It's like, it's difficult to express the magnitude of, like, if you've got something if Optimus, I think, could probably achieve 5x the productivity of a person per year because it can operate 24/7. It doesn't even need to charge; it can operate it tethered, so it's plugged in the whole time. That's why I call it like a future of sustainable abundance, where working will be optional. There's a limit to how much AI can do in terms of enhancing the productivity of humans, but there is not really a limit to AI that is embodied. That's why I call it the infinite money glitch.
I mean, one thing which I'll further add is, people forget, like, our first iteration of autopilot was 10 years back. So, Elon had started this way back in the day.
We've got the tweets to prove it.
Exactly. And then even on the Optimus side, right, as much as people think, okay, this is a new thing, I still remember, was it 4+ years back, we were in a finance meeting with Elon, and Elon said, hey, our car is a robot on wheels. And that's where we started developing. In fact, most of the engineering team, which is working on Optimus, has come from the vehicle side. And that's why, when we talk about manufacturing prowess, we have the wherewithal because the same engineers who worked back in the day on drive units are working on actuators now. So that's where we can do, if there is any company which can do it at scale, that is going to be us.
But we also have actually added a lot of new engineers as well to the team. So there's actually a lot of the credit for the Optimus engineering is actually also new engineers, many of them that are just out of college, actually.
Yeah.
So the Optimus engineering team is a very talented engineering team. I'd say, like, wow, actually. So, the Optimus reviews at this point are there's the engineering review, and then there's the manufacturing review being done simultaneously with an iterative loop between engineering design and manufacturing. Because then we see we design something and we say, like, oh man, that's really difficult to make. We need to change that design to make it easier to manufacture. So we've made radical improvements to the design of Optimus while increasing the functionality, but making it actually possible to manufacture. Like, I'd say Optimus 2 is almost impossible to manufacture, frankly. But to Vaibhav's point, we've gone from a person in a robot outfit to what people have seen with Optimus 2.5, where it's doing kung fu. It was like Optimus was at the Tron premiere doing kung fu, just out in the open, like with Jared Leto. Like, there wasn't nobody was controlling it. It was just doing kung fu with Jared Leto, at the Tron premiere. You can see the videos online. Actually, the funny thing is, like, a lot of people walked past it thinking it was just a person, even though with Optimus 2.5, you can see that it has a waist that's 3 inches wide, which is obviously not a human. But the movements were so human-like that a lot of people didn't realize they were looking at a robot. So, and what I'm saying is, like, Optimus 3 will be a giant improvement on that, and made at scale. But like I said, a very difficult thing. The Optimus, sort of engineering and manufacturing reviews, and there's the Friday night meeting with Optimus, which sometimes goes till midnight, and then my Saturday meeting is with the Saturday afternoons with the AI 5 chip design team. So those two things are crucial to the future of the company.
Great. And Dan, did you have a follow-up?
Yeah, I mean, just as a related, maybe you could just talk about to what extent are the AI efforts at Tesla and xAI complementary, or are they just different forms of AI? Maybe you can just help distinguish for the audience. Thank you.
Yeah, there are different forms of AI. So the xAI, so Grok is like a giant model that you could not possibly squeeze Grok onto a car. That's for sure. It is a giant beast of a model. It's with Grok, it's trying to solve for artificial general intelligence with a massive amount of AI training compute and inference compute. So, for example, for Grok 5 will actually only run effectively on a GB300. That's how much of a beast that Grok 5 is. So, whereas Tesla's, models are, I don't know, maybe about less than 10% the size, maybe closer to 5% the size of Grok. So, yeah, they're really coming at the problem from very different angles. xAI and Grok are they're competing with Google Gemini and OpenAI ChatGPT and that kind of thing. So and some of it's complementary. I mean, for example, for Grok Voice, being able to interact with Grok in the car is cool. Grok for Optimus voice recognition and voice generation is Grok, so that's helpful there. But they are coming at it from kind of opposite ends of the spectrum.
I appreciate you bringing up the challenges of hand dexterity in humanoids, along with the complexity of the supply chain and the vertical integration you guys are pursuing. I'm just trying to harmonize the timeline for the start of production, next year with the current state of the supply chain, and what sounds like a fair amount of work remaining on the dexterity before you can really freeze the hardware design and start to scale up production.
Well, we're not, the hardware design will not actually be frozen even through start of production. There'll be continued iteration because a bunch of the things that you discover are very difficult to make. You only find that pretty late in the game. So we'll be doing rolling changes for the Optimus design even after start of production. But I do think that the new hand is an incredible piece of engineering. And that's well, like I said, we'll have a production intent prototype ready to show off in Q1, probably February or March, and then we're going to be building a million unit Optimus production line. Hopefully with a production start towards the end of next year. But that production ramp will take a while to get to annualized rate of 1 million because it's going to move as fast as the slowest, dumbest, least lucky thing out of 10,000 unique items. But it will get to 1 million units, and then ultimately, we'll do Optimus 4. That'll be 10 million units. Optimus 5 maybe 50 to 100 million units. I mean, it's really pretty nutty.